This week on LCARA HAMRadio, we're going to take a look at the DX Commander Signature 9. This vertical dipole antenna is really easy to put together, and the results are spectacular. We're going to tune it, and we're going to make some contacts. That's what's coming up this week on LCARA HAMRadio. Alrighty, welcome back. I'm KY4BDP Brian, and KY4CKP is here as well, but he's off camera. He's going to be helping me a little bit today as we put together the Signature 9 multi-band antenna from DX Commander. Got the box here in front of me. I haven't opened it, so we're going to do a really quick unboxing just to kind of show some of the things that are in here. Then we're going to go to the user guide and we're going to begin creating our elements and so forth. Elements are very important, but the cool thing about that is Callum has a build guide. It shows you what length to use for your elements to make it very, very easy, because he's done all of the testing up front. There's a little bit of fine tuning on some fold backs and so forth, but other than that, it should go pretty well. Now, this is the Signature 9, and what makes it a little bit different than, say, the Classic is that you don't have to use any type of guy lines with this antenna. It actually utilizes a pole that you affix into the ground, and then the overall tube, the telescoping part of the mast, fits over top of that, and you don't have to have any guy lines, and that's one of the reasons why I got this particular model. Chris has done a couple of videos, at least on the Classic, that does in fact use those not radials, but the guy lines, and those work out just fine. But I thought, well, why not try a slightly different model that doesn't require those guy lines? So in the next segment, we're going to unbox all of this, and we're not going to belabor pulling everything out. We'll just put it out here on the table where you can see it, and then we'll go from there. Alrighty, so we've taken everything out of the box. We've got a lot of the bungee cord and some of the, he doesn't use hose clamps, but he uses something kind of like that to make sure that certain sections don't fall. We've got some electrical tape in here. We've got lots of radial ends to put on, little spade connectors that we'll have to crimp on and add a little solder to, a little plastic tubing, clear tubings in here, nuts, washers, a lot of your hardware, and what I would call nylon wear for the various elements and so forth that you're going to put up, plus making sure that your mast stays up. We've got some stickers, and we've got an SO239 with a spade connector on the end that will connect to the bottom conductor plate, as we'll see a little bit later. Always nice to have a few stickers. We've got 200 meters of DX10 wire that Callum has purposely sourced for these projects, for the various antennas that he sells today, and there's 2 of these bundles, so that's 200 meters total. You'll have one roll typically for your elements, and then you can use the other roll for your radials. And then we've got these plates and so forth. We've got the bottom conductor plate, but these white pieces here will ultimately go at different points on the mast as you're holding up the various elements. Remember, this is a fan dipole vertical orientation, and we need these to make sure that those elements stay at an equal distance from each other, and certain bands will have to be opposite and that sort of thing. So that is in here in this box. Plus we've got this guy. This is probably the actual conductor plate here, because you can see this is where we're going to connect our SO239. But in any event, all of the bits that appear to be in the videos are in here. Now we've got to start beginning the build process, which will be actually cutting those elements. And again, Callum provides a table for the different antennas that he sells, what lengths you need to go ahead and cut, and he actually has them a little bit long than you need. You can do a little bit of fold back on some of them, and do some tuning, some very minute tuning on those fold backs, which we'll see a little bit later. All right, so we've cut all our elements, and what Chris and I are showing you now is for 10 meters. This one's not very long. Again, the build kit or the user guide has the lengths that he suggests. I think Chris and I ended up cutting these a little bit longer than they needed to be, but just a little bit longer, not a lot bit, just to make sure we accidentally didn't do anything too short. But this is one of the elements. Now this is using his specific wire that he has source called. He's calling it DX10, and what Chris is showing you is it's very flexible, and it'll be easy to use once we string it up on the mast. So this is one of the elements, and again we've got 40 meters all the way down through 10. 30 is, we did cut a 30. I don't know how much I'm going to use that. I may end up changing that to just 6 meters. I believe Chris, you did that with one of his antennas, but we did cut one for 30, and so we're going to build it just like it's sourced in the user guide, but may end up actually throwing that one out and just going to 6 meters, because I probably will use that more than 30. Those are the elements using the wire he supplied. We've only used part of one of the spools thus far, and we still have another spool. Remember, we also need ground radials for this, and so we'll be using a lot of the other wire for the bundles of radials that go around the bottom plate. So in the next segment, we're going to talk a little bit about putting these ends on. We'll probably show you some roll of us putting some ends on, maybe a dab of solder, and to get these ready for connecting not only to the bottom plate, but ultimately actually being strung up across the mast. So we wanted to show you a few of the tools needed for taking the DX10 wire. So here we're just stripping off some of that insulation or outer jacket, and eventually the camera will focus. Sometimes you got to put your hand under it. But this is going to give us a little bit of wire to work with that we'll then be able to put our spade connector on. Chris is showing you there, or maybe this is my hand model, of we've got the heat shrink already on there, and now we just need to crimp on one of the spade connectors like you see here. So we've already gone ahead and crimped, and now we just need to move that heat shrink up over it, and we get out our trusty heat gun and make that heat shrink. It never hurts to have the tools of the trade when you're working with ham radio, and especially when you're working with cables, coax, and in this case, the elements for this vertical dipole antenna. Chris also wanted to do a quick comparison of the old DX Commander. You can see it's much thinner there on the left, the individual elements. The elements on the right are the new DX Commander Signature 9. Alrighty, so we've got the pole laid out here. Callum recommends measuring each section so that they're roughly the same length. And I would emphasize roughly, but he does say you may have to get forceful with some of these links to make sure that they come out all the way. So I have done that, and Chris is checking on fitment, making sure the screws on the plates are going to work. Take a look at his progress over here. And again, because he's built two of these, he has his own tips and tricks. So alrighty, we'll be right back. So we've put on the SO239. It has a lock ring right here where my finger is, so we've tightened that down. There's also a little piece where you can maybe attach a cap so that you can put a cap on this end. We've left that off because this is going to be more or less a permanent install. Alrighty, so we're going to get started now that the mast is fully extended, and we've attached the SO239 to the bottom drive plate. We're starting to move these other plates down the mast. And this plate is the other metal plate that the elements are actually going to attach to. And ultimately, the center conductor of the SO239 is also going to connect with a little bolt and wing nut to this second metal plate made of aluminum. Chris can show you that we're making sure to align these two plates so that little center hole will line up with the center conductor wire there, and then eventually we're going to attach the spade connector there to a wing nut, or underneath a wing nut. The other thing that Callum has included with this kit are these nylon hose clamps, if that's what you want to call them. I'm really familiar with the metal versions of these, but he was talking about how the metal versions will work, but they're not ideal with these types of masts. So he's gone with this nylon version, and you get the screw started, and then you can just put a wrench on it, or as they like to say in Great Britain, a spanner. So Chris is going to tighten this, which basically you'll see the length of the nylon getting a little bit longer. And now we can see the SO239 center conductor is connected. And we begin taking these other white pieces. Now these act as guide plates, if you will, for the various elements that we're going to install just a little bit later. So you just slide these down until they won't slide any further, or they won't go past the next segment, and then we'll use another one of those nylon hose clamps to basically keep it in place.
We were going to put one of those.
So the nylon hose clamps not only keep that plate from moving around, but it also prevents the top, the section just above of the mast from falling down into the larger piece below it.
What you got going on down there?
Oh, okay, yeah. We'll also want to make sure as we continue to add additional guide plates here that they roughly align, the holes roughly align, so that, again, the elements will be straight up and down. And we can do final adjustments to those plates once we have the elements actually installed. But it's relatively easy putting this together once the mast is fully lengthened out. And utilizing these sawhorses makes it really easy because you put it at a good working height.
So we've got the hose clamp with the rubber tubing on the very bottom to keep it nice and snug. Then we've got our first guide line plate, if you will, guiding plate with one of the black nylon versions, a black nylon version for those two sections, another guideline plate plus nylon. You can see we've already trimmed a couple of these. So Chris is in the process of tightening down one of the last ones. That's the second to last guiding plate. And then he's tightening that one down. And then we have the last guide plate up here. And again, you want to make sure these are roughly in the same alignment. We're going to go and do a better fitment alignment in a little bit, but get them roughly where they need to be. And then on this very last section where these two come together, typically what he recommends there is just put a little electrical tape on the thinner side here, and that'll prevent it from sliding down.
So the next order of business is to take some of this shock cord, or basically tensioning cord, and Callum shows a couple of different knots that you can utilize on the ends of these cords. Chris is showing you what is basically a double loop here on the end. This is going to prevent the cord from coming through on the guide plate, and then we use the other end to put tension on the element so that it's straight up and down.
Now we got to put a knot on this end, don't we? I want a decent amount of it sticking up, so yeah. So see, if it was just dirt with that length of pipe, I don't think that would be enough. So, but with Quikrete, you'll have enough weight. I think it'll do better. Now that makes it more permanent, but that's all right. So what you're supposed to do is, with some of the wire that come on the rolls, you want to cut 4 equal length pieces of wire. You're going to bundle these. We're going to show you basically the step-by-step process, but we're going to strip the wire on the ends, put a spade connector on the end, and then we're going to put some heat shrink over that. So this is setting up the radials, and there's 6 bundles of 4.
All right, so now we're going to take these 4 wires, we're going to strip off some of the ends, we're going to bundle them together, and then we're going to apply some heat shrink and utilize our heat gun to make sure that that heat shrink conforms to that bundle, and that'll keep the bundle basically in place. Here we're actually crimping one of the connectors on the end. So we had our wire all twisted together, and now we're going to clamp all that down and then move the heat shrink up above it.
Well, the day is almost over, and KY4CKP has gone ahead and headed back home. But I tell you what, having 2 sets of hands to put this together really was helpful. And of course, he's built 2 of these over the years, and he was very much instrumental in keeping me on the straight and narrow putting this together. And the The user guide that Callum supplies is more than sufficient in most respects. So between Chris's experience and Callum's directions, this turned out nicely. I like the way these two metal plates come together and the connector. You can see the cap is on the end, and that we'll take this off tomorrow, and that will then create the void on the inside of the main mast piece here, this segment, and then that will go over the supplied fiberglass tubing here that we've concreted in at the very bottom to give it some ballast. I just wasn't comfortable. Callum actually just packed the dirt where he is there in the UK to create the mast portion here, the anchor point, but I didn't feel comfortable with that. My dirt has enough sand in it that I just didn't feel like it was going to stay, and if it got windy it would just become wobbly over time. So we've added some concrete. This is just one bag at the very bottom, and then I'm going to fill up the hole with the dirt that we pulled out of there tomorrow. So this will be day 2 when we come back in the next segment. But I'm really chuffed, and now that these pieces are built and we anchor this into the ground tomorrow and attach the radials. Oh, let's not forget the radials. Now I've just got them on the ground over here laid out, but you can see we've got the radials here, and let me just pull up one of the bundles. We've got the end there affixed and crimped on and heat shrinked, and this is a bundle of 4 wires 16 feet long, and Callum has done an enormous amount of testing as far as you know, other lengths and so forth, and what it really comes down to for most people is that 16 feet is going to be sufficient. If you want to add to it, you can. If you wanted to go with shorter on some and longer on others, you can. If the place where you install this wouldn't allow you to do 16-foot radials, you can use shorter. So ultimately, we went with 16 foot. Seems to be what Callum recommends as kind of a compromise, and that should work. And we're going to attach those once we get this actually attached to the anchor over here, the mast anchor, so we don't have to use guy lines. Now, once all that's in place, and that won't take but about 10 or 15 minutes tomorrow morning probably, we're going to connect a cable, and we're going to begin the tuning process. Alrighty, so we put the dirt back, or some of it at least, in the hole that I dug yesterday. Of course, there's concrete below all of that to give it some good ballast down at the bottom, and plenty of poles sticking up to give the Signature 9 a nice level vertical. Made some adjustments to the guiding plates, make sure that they weren't moving around. That top guide plate really needed a little extra help, but that's all right. And made sure that the 40 meter that comes back on itself there at the top, keeping the 2 ends of the wire on opposite sides of the pole so they don't interact as much, or we hope they don't interact very much. But anyway, that's the proper way to do it. And then you've got your very bottom plate sitting on the ground, and that will ultimately be the plate that the coax will connect to. You can see the SO239. It is also connected, the center element is connected to the driving plate, and then the bottom plate is ground, essentially. And we're going to put the radials now on that very bottom plate, and then make sure that those are spread out roughly evenly. So in the next segment, we're going to get those radials put on. We'll look at that. We're going to connect some coax and get to tuning. Alrighty, so we've got the coax connected, got our little center conductor underneath that wing nut, and we got our radials out there. And I've got to go back and put some stakes on these to keep them down a little bit, but eventually the grass will grow over it. At least that's what everybody says. I believe them. And then you can just mow over this like you normally would. I went ahead and mowed it really short so I can get the radials down to the ground as close as possible, but everything looks good. So to be honest, the next thing really is to go fire up an analyzer. I may cheat a little bit and go to the radio directly and just see what kind of SWR I'm getting, and because the ICOM 7300 can tune anything below 3, so we can test some of the bands here pretty quickly and get a feel for whether or not any of these are too long Typically they're not too short because Callum ensures in his build chart the length that you want and the loop that you want to achieve pretty good numbers right out of the box. But let's go test it out in the next segment.
Alrighty, so we're looking at 40 meters here. I did try my MFJ, but it's having some issues, so I'm just going to go straight to the ICOM 7300 and check the SWR with its feature. If you can get it below 3, the 7300 can tune it. So that's what we're looking for, is are we below 3 on the bands that we have installed? So I'm at the very bottom of 40 meters, 7.125 at least for voice. Let's check the SWR. Well, I don't know how much better you can be. It might be just a tad long because it's 1.0 at 7.125. You can see the blue just starting to peak up there at the very end. It was 7.185. But that's very good. That means if I wanted to do FT8 or something like that, it would be also very good. So I like it. I didn't have to touch anything on 40 meters at this point. Again, this is on the low end. Let's go to the high end and see what it looks like. Okay, so now what I've done is I've gone to where you can just see 7.300 on the far right, and we're at 7.180 to begin the check. I've got this on 13 bars for checking the SWR. So let's see what it looks like as we go up on the band. So it's tuned just a little bit low if you want to think of it that way, but all the way across the 40 meter band, it's fine. It's below 1.5. In fact, as we touch 7.300 there on the far right, we're right at 1.5. So everything to the left of that, as we go lower on the band, we are below 1.5 with no problems. And so you could just go ahead and run your radio just like this. You wouldn't necessarily have to tune it to come up with 1.0. So right out of the box, based on how we cut the wire length and folded it, not folded it, but had it come back on itself and keeping it separate, all of that is working. And so I'm very, very happy with 40 meters. Let's quickly take a look at some of the other bands. Alrighty, so I've moved on down to 20 meters. I do have a 30 meter element. I don't think I'm going to use it that much, so I'm going to skip it for now. But let's take a look at 20 meters. Now, right now, we're looking at 14.090 on the far left. 14.150 is kind of the beginning for voice, and then we've got 14.210 there on the far right, and I've got it ready to go. Let's see what the SWR looks like on 20 meters. So it started at 1.0 way over there to the right. So on the left, on the digital portion, can't get much better than that. At 150, where we really start voice, it's probably 1.2. And if we go over to 14.210, we're at about 1.4. That's very good. Again, right out of the box. It's tuning, you know, if you don't do digital at all, it's probably a little long, and you could move that dip a little bit further to the right, but we're really just nitpicking at this point. Let's go to the far end of 20 meters, and let's see what the SWR looks there. Alrighty, so now we're looking at the far end of 20 meters. We've got 14.230 on the left, 290 in the middle, and 350 there on the right-hand side. Based on the previous test, it's probably going to continue to go up, and it is. So you can see we've crossed the 1.5 threshold, but we're still below 2. So we're at about 1.9 on that far end. Still below 2. Easily tunable by this particular radio. And again, if I wanted to, I could shorten that element a little bit and move the low end of this towards the middle of this band. Again, it just depends on how you're planning to use 20 meters. Are you going to be using voice more? You probably want to shorten this element a little bit. If you were going to maybe focus more on digital, you might leave it right where it is, but it's perfectly happy where it is right now. Don't let that red fool you. Anything above 1.5, you probably don't want to run per se, but let the transceiver, in this case, tune it, and you'll be down to 0. So this element is really in a really good spot already. All right, let's test one more, probably a band that I will use to some degree in the next test. Alrighty, so I'm on 15 meters at this point. You might say, well, Brian, you're going to use 15 meters a lot? Not really, but I did find something off camera, and of all the bands, I'm just going to go ahead and let you in on a not-so-secret. All of the bands look great. A couple of the elements are a little bit long, but still are below 2. across the bands. 15 is the only one that's giving me problems. So let's take a look at 15 meters here. Now I've got 21080 on the far left, 21200 on the far right. And if we look at the SWR, you can see it's below 3 at this point, really low on this band. 21 megahertz is basically where it starts, so we're just a little bit to the right of that. But you can see it is below 3, but as we continue across, now it's touching 3, right at 21,140-ish. So this element is too long. How much long? We'll have to shorten it a little bit and see if we can pull this over. But it is too long, and as we go across, of course, it just continues to touch the band. Now, if we tune this, because a portion of this band it was below 3, it will tune this. So let's start it again. You can see 1.0, and then it starts coming up. So I can tune this band, but it would be nice to go ahead and just shorten that element a little bit. It just means taking the antenna down for just a moment, and it's so easy to do with the DX Commander because it's so light. So let's take the tune back off. You can see we're just below 3 on the far left, and then it touches 3 after that. Tunable still, but it wouldn't be that difficult to shorten that element a little bit and move this, the low part of this, closer to the workable side of the band. So that's what we're going to do. 15 is the only one that I've come across. I've already tested the others with the radio here. They're all below 2, in some cases 1.0. I could adjust a couple of the elements just to shift it a little bit, but 15 is really my only problem child. So let's go and adjust it a little bit. Let's shorten that element somewhat, and then we'll come back and test it.
Alrighty, so I've shortened 40 meters by this much. Of course, I took out a little bit of the loop as well. So one of the things you learn about 80 and 40 meters, it takes a decent amount to remove, but you don't want to be too aggressive, like 2 feet or something like that. So I've taken this amount and then retaped it to create the loop. And now we're going to go back inside. I've already connected the antenna back. So you can see I've got my wing nut back in place. And let's go check 40 meters again on the 7300.
Alrighty, so we're back from doing a little bit of snipping and got it all back in the air as we just saw. And I had to remind myself that 15 meters actually tunes utilizing the 40 meter element. And if you remember, 40 meters was in a pretty good spot, maybe a smidge tuned low. So both 15 and 40 were tuning a little low, 15 a little more so than 40 meters. So that being the case, we had to trim, or I had to trim, the 40 meter element. Now I've gone back to 40 meters here just to see where it's landing. Remember, we're looking at 71.25 to 7.3. So let's check the SWR. And sure enough, it's practically 1.0 in the middle of the band, or very near. And so 40 meters tunes even better now than previously by taking off about 8 inches of that element. Remember, you're folding it back a little bit as well. Now, let's switch to 15 and see what happens. In this particular case, now we're going to record it again. So you can see it's a little better. It's moved a little bit to the right, to the dip. So not only did it achieve a better 40 meter result, but we are staying below 1.5 about across, all the way across the 15 meter band. So in our example here, we've achieved a better result. I could probably move it a little bit further. If I were more focused on 15, I could move the dip that we're seeing on the far left over to the right by shortening it further. But remember, we're using the 40 meter element for 15 meters. So I'm probably going to use 40 meters more than 15. This is very usable, and 40 is now in a really good place. If we go back to 40 meters, you can see how it tuned, and it is nearly perfect. Again, I could shorten it a little bit more and achieve a better result on both bands, but right now I'm pretty happy with that. So the DX Commander is now properly tuned for all of the bands, including 15 meters.
Those of you that have created your own antennas, you start nitpicking at what you've got. I was pretty pleased, but I thought I'll just take off a little bit more, and we'll tune it one more time. So got it snipped a little bit more. Not sure how much it'll really drift things, but
Let's take a look at it now. Okay, so I've made that last adjustment. Again, you can get kind of obsessive about tuning these, but I just wanted to bring 40 a little bit closer to the middle as far as that 1.0 that we were seeing. We were getting 1.0, a little lower in the 40 meter band, but I just wanted to move it up a little bit. Let's run the SWR, and sure enough, I've hit it just about bang on. 7.225 is about the middle of 40 meters, and that's 1.0. So I've shifted it a little bit further, and I'm going to use 40 more than I'm going to use 15, but this will have an impact on 15. So let's go take a look. Alrighty, now we're on 15, and we're showing kind of the upper end of 15. The middle would be a little bit further down. Let's tune that just a little bit further down, and let's go to about 350. Actually, about 375. Yeah, sure enough, you can see that we're quite a bit below 1 now for a good portion of the lower part of this band. About 21.200 would be even lower, and we've shifted that quite a bit. And 21.450 is the upper end of the band. So if we move this just a little bit more, let's go to 90 here. That puts us at 21.450 on the far right. And now when we run this, you can see we're just above 1.5 at the very top end of the band. You might not even use that portion. So we're below 1 for, I'd say, 90% of the band. If we go back towards the bottom of the band, let's go back this way. So this puts us at 210. Let's go up just a little bit more to 80. There we go. You can see that we're comfortably below 1, and that will include potentially digital on that. I can't remember on this band where the digital is, but we've improved both 40 meters and 15 meters, not substantially. Well, for 15 it was substantial, but for 40 we've moved the dip closer to the middle, and we've moved 15 to where it's much more usable across the band without really any tuning on the radio at all. And that's what's great about this type of an antenna. Not just the DX Commander, but other fan-based dipoles. You can adjust the lengths of those elements to your heart's content to basically center that dip wherever you want it. And that's what we've achieved. Alrighty, so it's been about a week since we initially put this up, actually about 2 weeks. And I wanted to finish out the video by showing the antenna, DX Commander Signature 9, all put together. I have gone back and ensured that the tension cords and the elements are not going to come apart. I've also installed the radials, and they're starting to kind of melt into the grass a little bit. Melt is probably not the right word, but kind of settling into the grass. You can see it here in this shot. There's about 4 of them there. Now, some of them are still a little bit high, so I'm going to give it a little bit more time, but eventually I'll be able to mow this area with no issues. Of course, I'm not going to mow it at its lowest setting. And the best way to test an antenna, now that we know what the SWR was on all of the different bands, is let's go do some POTA activations. So we'll be a hunter today, a POTA hunter, and we're going to test some of the different bands and see how well this antenna gets out. So I'll be back in the next segment. Alrighty, I found a Parks on the air on 40 meters here at 7.211. Little bit scratchy today using this antenna, but let's see if we can make a contact with this Park out of DC. Kilo Yankee 4, Bravo Delta Papa. Kilo Yankee 4, Bravo Delta Papa, you're 5-9 into Tango November.
Copy, 5-9 Tango November, Kilo Yankee 4, Bravo Delta Papa, you're 5-8 into the District of Columbia, Kilo 0656, over.
QSL, thanks for the activation. Happy trails.
All right, thanks my friend for hunting. Hope you have a good one, 73.
Alrighty, so we got one activation there. A little bit scratchy on 20, but this antenna appears to be extremely sensitive in a way, so I've been switching back and forth between an off-center fed dipole and this one. In fact, let's switch to the off-center fed dipole. You can see some of that noise goes away, but I don't know what to attribute that to necessarily. The signal is about the same, and the scratchiness is about the same, but he's a little bit clearer there. But if we go back to the signature 9, he's certainly there. So from the standpoint of the display, looks like a little bit more noise is coming in there. But again, this is very copyable as a Parks on the Air. Let's see if we can get one more. I'll be right back. Kilo Yankee 4, Bravo Delta Papa. QSL, you're also about a 5-3, 5-4 into Tango November. Alrighty, so we made the contact, but just barely can hear him, and when we go spot him, we can certainly say it was around a 5-3 at best. So, but we did make a contact. So we've made a contact on 40, a contact on 20, and sometimes there'll be other contacts. Let's see if we can pull in one more. So we got another 7.215 here on 40 meters. Let's see if we can pull him in.
I got you 5-9 here in Illinois. All right, thank you for the 5-9 into Illinois, 73. QRZ.
Kilo Yankee 4, Bravo Delta Papa. QSL, you're about a 5-8, 5-9 into Tango November. Alrighty, so we got another one. So again, anytime you set up an antenna, one of the best ways to try to test it out after you've checked your SWR and so forth is to look for these Parks on the Air activations. And that way you can actually see if the two-way communication is working well for you based on how you've got your antenna oriented and installed. Let's go wrap up the video. So as the sun goes down here at Tiny Fangorn, we were able to make some contacts on a couple of different bands. And as we check the SWR, things are looking really good. Can't wait to use this antenna some more. And you can see the tower in the background. We've got another series on that, plus the shack here. And we hope you've enjoyed this video. If you like this video, subscribe, hit that like button, and let us know what you think of the DX Commander Signature 9. Take care, everybody. Thanks for watching, and 73.